Okay, we're still in chapter 1, point number 15, multiples of a number. Now, when I'm trying to find the multiples of any number, what I do basically is I ask myself what this number multiplied by 1 is. It's the number itself, of course. So this is always the first multiple of a number. Then, what is the number times 2? 24, for example, for this example. So that's the second multiple. 12 times 3, so 36. 12 times 4, 48, and so on. So I multiply the number first by 1, so that's a number itself. Then I multiply by 2, 3, 4, and so on and so forth. These are the multiples of numbers. Now, as I said before, factors and multiples are both very, very simple. But because they're very simple, do expect them on the test. You will have a problem because if they're very simple, as you can see, you need to do them quickly and you need to do them right. So don't think they're too simple, so you try to do them too fast, and then at the end you have a problem because you were too fast, so you weren't accurate enough, you got a wrong answer. And the same also, don't do it too slowly so that you don't get a right answer after a long time. So we need to balance. You need to practice easy stuff like finding multiples and factors, because you will need to do them on the test. You want to do them quickly and you want to do them accurately. Okay, now let's go to number 16, exponents. Exponents are powers. Basically, if I have a number like this, 5 to the power of 6, this is called the base and this is called the exponent or the power. This means 5, which is the base, times 5, 6 times. So 1, 2, 3, 4, 5, 6. Sorry, 6. So 6 5s. 5 times 5, 6 times. This is 5 to the power of 6. Okay, now let's go over some basic notes here. If I have any number to the power of 1, like 23 to the power of 1, then it is the number as it is. If I have a 10 to any power, simply the answer will be 1, and next to it, a number of zeros equal to the exponent. So 10 to the power 7 is 1, and next to it, 7 zeros. So that's 10 million. Special names. Now, we have square. A square is a number squared. So if I say 3 squared, that means 3 times 3. 3 to the power of 2 is 3 squared, which means 3 times 3. Cubed means to the power of 3. So 3 cubed is 3 times 3 times 3. Now, we have something called a perfect square, which is a number that equals a number squared. For example, 4 is a perfect square. Why? Because it equals something squared. It equals 2 squared. Is 6 a perfect square? No, because it doesn't equal anything squared. So 6 is not a perfect square. Is 9 a perfect square? Yes, it is, because it equals 3 squared. So any number that equals a number squared is called a perfect square. Similarly, a perfect cube is a number that equals a number cubed, and cubed means to the power of 3. So is 8 a perfect cube? Yes, it is, because it equals 2 to the power 3. Is 16 a perfect cube? No, because it doesn't equal anything to the power of 3. Is 27 a perfect cube? Yes, because it equals 3 to the power of 3. 3 times 3 times 3 is 27. Now, what is a number that is both a perfect square and a perfect cube? A very famous number here is 1, because 1 equals 1 squared. Remember, 1 to the power of anything equals 1, and it equals also 1 cubed, because 1 to the power of anything equals 1. So it can be considered a perfect square and a perfect cube at the same time. Okay, now after that, let's go on to the next page, basic rules of exponents. Now, basically, we can do two things with exponents. We can either multiply or divide if you have the same basis. So, if I have 3 to the power of 2 times 3 to the power of 3, that equals, first of all, the base is the same, 3. Then what do I do to the powers? I add them. So 2 plus 3 is 5. Another example. 4 to the power of 6 times 4 to the power of 9 equals 4 to the power of 9 plus 6, 15. What about division? 4 to the power of 6 divided by 4 to the power of 4. When there's division, we subtract the powers. So it's 4 to the power of 6 minus 4 is 2. Another example. 16 to the power of 9 divided by 16 to the power of 2 equals, same base, 16. Since it's division, so we do 9 minus 2, 7. So 16 to the power of 7. Now, if the bases are not the same, the 3's here and the 4's here, if they're not the same, we can't do anything about it. So let's say we have something like this. 3 squared times 4 to the power 6. There is no way, there are no rules for this. Okay, the only way is to actually find what 3 squared equals by itself and what 4 to the power 6 equals by itself, and then multiply them. But there is no rule. You can't do any addition or subtraction or multiplication or anything with numbers that have different bases. Okay. Let's go on to the next page. Okay. Square roots or radicals. A square root is basically the inverse of squaring of a power of 2. So basically, if I know that, for example, if I know that 2 squared, 2 to the power 2 equals 4, then the square root of 4, which is the answer, equals the original number 2. Okay. 4 squared equals 16. That means that the square root of 16 equals 4. So what is under the square root is the number that is the square, okay, the power of 2 of the answer. So 4 is 2 to the power 2, 16 is 4 to the power of 2. Now this is all very simple and very basic. We're just going over the main points here quickly. Okay, let's take a look at the note underneath here. Now, multiplied values or divided values under root can be rewritten as 2 roots, and this comes in handy sometimes. For example, let's say you have something like this, the square root of 9 times 16. You don't have to multiply 9 times 16 without a calculator, remember, and then find the square root of the answer. You can just rewrite this as the square root of 9 times the square root of 16. The square root of 9 is 3, the square root of 16 is 4, so the answer is 3 times 4, 12. Okay, what do we have next? What is a factorial? Okay, before we start with factorial, in exponents there are a few tricks, a couple of points very important that we will use frequently on the test and that are pretty hard to do without a calculator. We're going to discuss this in the final math chapter in the book, so it's going to come in a few videos. Okay, number 18, factorial notation. Now remember what a factorial is? Basically, it's this sign, the exclamation mark. Any number with a factorial or an exclamation mark afterwards means it is the number times the number right before it, integer right before it, times the integer right before it, all the way until you go to 1. So, what is the factorial of 4? It is 4 times 3 times 2 times 1. Or, another way to write this is 1 times 2 times 3 times the number itself. What is factorial 10? 1 times 2 times 3 all the way until you stop at 10. Okay, a trick. When you divide factorials, a lot of the numbers cancel out. What does that mean? Here, let's say we have a question like this on the test. Factorial 5 divided by factorial 4. Now, we can do this two ways. First way is you can find the factorial of 5, again without a calculator. So you do 1 times 2 times 3 times 4 times 5. You multiply all this, you get a number. And then you do the same thing for 4. 1 times 2 times 3 times 4. You multiply all of these, you get a number. Then you divide both numbers by each other. However, there's an easier way. How? Isn't factorial 5 divided by factorial 4 the same as factorial 5 over factorial 4? Factorial 5 equals 5 times 4 times 3 times 2 times 1. Factorial 4 is 4 times 3 times 2 times 1. Now, all of the numbers in the numerator are multiplied by each other, all the numbers in the denominator are multiplied by each other. So we can simply cross out the same numbers from top and bottom. So this 4 cancels out with the 4, and the 3 with the 3, and the 2 with the 2, and the 1 with the 1, leaving you with just 5. So the answer is 5 right away. There's a special case in mathematics, and it is the factorial of 0. The factorial of 0 always equals 1, not 0. Number 19, the order of operations. Order of operations is very important. There are standalone questions on the test that just need you to use the order of operations properly to get the right answer. And sometimes you will need to use it as part of a longer problem. Now, the order of operations, PEMDAS, means that we always do things inside parentheses first, then exponents, then multiplication and division from left to right, whichever comes first. Then addition and subtraction from left to right, whichever comes first. We remember them as PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Okay, the example right here is pretty simple. Just take a look at it, please. Okay, the number line, very, very basic. You learned this in first grade. Basically, a number line has equal spaces from negative numbers all the way to positive numbers passing through 0. Just remember that the number on the right is always bigger than the number on the left, even though the digit may not be so. For example, if you look at this here, negative 4 is bigger than negative 5. Okay, just don't forget that, because negative 4 is to the right. It's closer to 0. But 5 positive is bigger than 4 positive, because it is to its right. Number 21, absolute value. The absolute value of any number is basically the positive value of that number. It is the number without a sign. So the absolute value of positive 7 is positive 7. And the absolute value of negative 7 is positive 7. Okay? So the absolute value of any number is the positive of that number. Absolute value of negative 15 is positive 15. Absolute value of 0 is just 0. Absolute value of 1, 2, 3, 4 is 1, 2, 3, 4. Of negative 1, 2, 3, 4 is positive 1, 2, 3, 4, and so on. Now, make sure if you have an absolute value question and there's something inside, like an operation like subtraction, for example, you always do that operation first. So let's say we have something like this. 3 minus 7, absolute value. First thing we do is we do what is inside the absolute value. Think of them as parentheses. Remember, in order of operations, the first thing we do is parentheses. If you have absolute value, it's the same as parentheses. 3 minus 7 is negative 4. So we're looking for the absolute value of negative 4, which is positive 4. Okay. Number 22. Adding and subtracting with positive and negative numbers. Very simple. If the signs of the two numbers being added or subtracted are the same, then the answer is always going to be with the same sign. So positive 5 plus 2, everything is positive, the answer has to be positive 7. Negative 5 minus 2, the answer is still going to be 7, but because they have the same negative sign, it's going to be negative 7. If the signs are different, one is positive and one is negative, then the answer is always the big number minus the small number, with the sign of the bigger number, or the bigger digit. Meaning, 5 minus 2 is going to equal 3, but positive 3. Why? Because it's like the bigger digit, 5, like the bigger number 5. 2 minus 5 is going to also be 3, but it's going to be negative 3 this time. Why? Because the negative was with the bigger number, which is 5. Multiplying and dividing positive and negative numbers. Here, let's take a look here. Now, we have the following cases. If you are multiplying numbers that have different signs, the answer is always going to be negative. So a positive number times a negative number, or a negative number times a positive number, always gives me negative. So let's say positive 3 times negative 6 equals negative 18. Since one is negative and one is positive, the answer is always negative. However, if both numbers are the same sign, then the answer is always going to be positive. Like Positive divided by positive is positive. Negative divided by negative is positive. Same thing. Positive times positive is positive. Negative times negative is positive. Okay? Positive divided by negative. Since they're different signs, then the answer is always negative. Negative divided by positive. Different signs, always negative. Okay, let's do a couple examples here really quickly. So if I say 3 times negative 6, we said negative 18. 3 divided by negative 2 is negative 3 over 2. 4 divided by positive 2 is positive 2 because they're both positive. 4 divided by negative 2, since they're different signs, so it must be negative. Okay, let's go on to the next page. Important note, you should never leave two signs, positives or negatives, next to each other without a number in between. This rule is so important that I'll write it again, and now I'm going to just say it again. You should never leave two signs, positive or negative, next to each other without a number in between. Now, that does not mean that you should put a number in between any two signs. It means basically that when you have two signs next to each other right away without a number in between, you need to change them into just one sign. So two positives after each other is just a positive. Two negatives is positive. A positive and a negative is negative. A negative and a positive is negative. So if I say 3 plus positive 5, that's just like saying these two pluses become 1 plus, so 3 plus 5. Two negatives next to each other become also a plus. A positive and a negative, or a negative and a positive, become negatives. So let's do this example right here together. Last one. 5 plus negative 3. 5 plus negative becomes 5 minus 3. The plus and the negative become minus. Plus and minus again become minus. Minus and minus, two negatives after each other, become plus. So it becomes 5 minus 3 minus 2 plus 5, which is 5. Okay, last point here, 24, coordinates on a grid. Just make sure that you remember how to name or to identify any number on a grid, on XY grid like this. For example, this point is called B1 and 2. The 1, the first number is the X, and the second number is the Y. So here is 1, so my X is 1, and here is my Y, 2, so my Y is 2. Let's take this for example. What are the coordinates of this point K? 1, 2, 3, 4, 5. So the X is 5. What about the Y? 1, 2, 3. The Y is 3. So the coordinates of point K are 5 and 3. The X is 5 and the Y is 3. Okay, we're done with chapter 1, and I'll see you guys in the next video for the following chapters. Hope you understood and everything is fine. If you have any questions, don't hesitate to send me an email at any time.